abundance, diversity, and habitat structure. These are affected by the compounding of impact of massive coral bleaching, disease, and typhoon. So it is estimated that around 30% of it were already destroyed, while almost 60% of it may be gone by 2030. Similar observation was also discovered in the Philippines, where local reef are declined over the last 4 decades. So national survey showed more than 90% of the same stations were in the poor, which is 0 until 25% of live coral cover, and fair, 26 until 50% of live coral cover categories. So it is having an average of hard coral cover around 22%. In Bicol region, living coral cover range from 30 to 60% of it and are continuously declining, and most of the reason for this low coral cover were anthropogenic, such as a destructive of fishing methods, navigation, and fishery resources. Fishery resources was tragically established along the coastal water of the Bicol region. So with the impact of the climate change and pollution, which increase a couple of high anthropogenic influence, coral can be easily affected. So that may also affect fisheries, other aquatic resources, people, and their livelihoods. So with declining of state of our coral reef, we need a conservation and rehabilitation efforts that are deemed crucial for ecological, biological, and economic recovery and stability of the reef system. However, as of the present of time, no concrete policy has been implemented to restore and even rehabilitate our reef area coastal ecosystem using the context of ecological approach models such as artificial coral reef, electric mineral growth technology and reef ball technique, and transplantation of re-rigged coral fragments. In 2012 until 2014, the Department of Science and Technology founded a nation coral restoration program named Philippine Innovation in Coral Reef Restoration Program, where in Bicol region, especially in San Fernando, Masbate of one of the project location. So the main purpose of the nationwide reef restoration was to demonstrate the viability of the reef restoration technique in Philippines, to encourage local government units to adopt the methods and implement such as in their coastal area. While the demonstration site in San Miguel Island was done to showcase low-technology coral restoration scheme utilizing locally available materials and reduce a possible cost of restoration process.
Now, I will be presenting the methodology used for constructing modules for coral nursery. As seen on the map, the project was carried out in 3 locations, which is San Fernando, Masbate City, and San Miguel Island in Tabaco City. Each site utilized different coral nursery techniques tailored to the local conditions. In San Fernando, we employed the hangar-type T-model coral nursery unit of CNU. This unit was built using 3 PVC T-seating, each 3 meters length with a width of 1.5 meters and a depth of 1.5 meters. The structure included 18 series of 6 mm ropes spaced 10 cm apart. To enhance stability and minimize movement, 70 GI wire was connected perpendicularly to the ropes. The inset photo on the slide shows the nylon ropes embedded with the GI wire for added support. In Masbate City, a bed-type CNU was utilized. This structure was created using plastic chicken mesh nets reinforced with iron bars. This design provides a stable and durable platform for coral propagation, particularly in areas with varying currents. Lastly, in San Miguel Island, a combination of bamboo raft and a monoline technique was used. The bamboo raft acts as a floating structure, while the monoline structures suspend the coral fragments to promote growth in controlled environments. Deploying the coral nursery unit requires 2 diver teams and the installation of 2 metal posts secured with PVC framing and anchored with rebar tabs. For low-cost methods, local coastal rangers assist in deployment using bamboo raft and monoline CNUs stabilized with rocks or pads during low tide. So, how to manage coral newbins? Coral newbins are collected from corals of opportunity, which is known as COP, fragmented into 10 cm pieces and attached to ropes using GI wire. Bi-weekly dive ensure maintenance by removing debris, predators, and falling organisms to promote coral growth.
Coral transportation involves several key steps. First, coral fragments are reared in sea and used for 4 to 6 months. The transportation process then takes place at rehabilitation sites where fragments are secured using concrete nails, cables, and aqua epoxy. Before transportation, the site is assessed for living coral cover, associated reef fishes, and commercially important invertebrates. It's essential that these sites are within marine protected areas, ensuring the newly transplanted corals are safeguarded. Community participation plays a vital role in this process. Organizations like the Municipal Fisheries and Aquatic Resource Management Council, Bante Dagat, and the Municipal Agricultural Office collaborate on tasks such as collecting coral fragments, preparing CNUs, securing nubbins, rearing coral fragments, and transferring them to the rehabilitation sites. Even the local women and youth contribute to these efforts, showcasing how inclusive this project is. Once the corals are transplanted, their growth and survival are monitored quarterly by the BUTC research team and trained personnel from the LGU. Key data collected includes percent living coral cover, survival rates, and the growth of transplanted fragments. Associated reef fishes and invertebrates are also recorded and compared to prior condition. Findings reveal that acropora coral fragments reared in nurseries exhibit an average monthly growth of 1 cm, which align with similar studies. Survival rates range from 60% to 80%, comparable to other coral restoration efforts. This method highlights the importance of combining science, community involvement, and monitoring to ensure successful coral reef restoration, preserving marine ecosystem for future generations.
So next we move to discussion part, which is the first point is cost of coral transplantation. So there are many questions whether coral transplants are the best way to restore damaged marine life ecosystem. It is maybe difficult to answer because there is no method to fit all. However, LGU needs to do something or they will lose everything. So this is table 1 shows the simple cost analysis in San Miguel Island. This is two method, which is bamboo rock and monoline method. The conclusion is with the low cost, monoline method can have 120 fragments survive from 200 number of fragments for the 60% survival rate. For the next discussion point is the additional economic opportunities. So by doing the coral restoration program, fisheries can be improved, lead to the sustainable ecotourism. With this ecotourism, the overfishing activities will change to the ecological friendly alternative. So as example, in the picture, this is demonstrate site in San Miguel Island, which they can develop coral rocks as for the education tourism purpose. So for the another example, there are marine protected areas in Legazpi City and Ligo City, which is highlight the coral reef ecosystem can attract tourism, especially during peak season like summer and holiday.
Okay, for the third discussion is about problems and challenges in the project. First is monitoring challenges. LGUs lack permanent staff to oversee coral restoration, and usually after an election, new officials may not prioritize this project, leading to budget cuts and interruption to continue monitoring. Second is threat on coral. There are two types of threat. First is anthropogenic threat, such as illegal fishing, and that continues to damage coral reef. And second threat from natural calamities such as frequent typhoon in Philippines and ocean warming, leading to coral bleaching and destruction. And lastly, challenges from technology limitation. Not all coral restoration method works on every area. For example, the same method approaches may be less effective in other area. And lastly, for the fourth discussion, is about the LGU's initiative and community partnership. First, we look into the legal framework. LGUs in Philippines have established laws to manage and protect municipal water, such as the Local Government Code and Fisheries Code. And LGUs also established environmental laws such as Clean Air Act, Solids Management Act, and Clean Water Act. Next, we look into LGUs action. LGUs in Philippines create regulatory and enforcement bodies, for example, MPH Management Council, FARMC, or the Fisheries and Aquatic Resources Management Council. And LGUs also establish programs such as Coastal Resources Management Project, Mangrove Restoration, and MPAs, and about 50 MPAs located in Bicol region. And lastly, we look into the good partnership. A good partnership leads to successful outcomes with a shared vision and purpose. For example, through LGU Community Fisheries Partnership, their success in doing restoration on Buntuk Reef in Masbate City, which become popular tourist destination, and restoration in Kobusu Kamirin Sur that turned into ecotourism spot for bird watching.
Okay, as for the conclusion, we can say that coral reefs in Bicol and worldwide are rapidly declining due to human activities and also climate change. Another reason is because MPAs alone are not enough to restore coral cover. Coral reefs are essential for marine life, fisheries, and also local communities. Restoration efforts have also been done by doing various projects that use coral nurseries and transplantation to restore reefs. Community participation and low-cost methods make restoration more feasible. It can also lead to ecotourism, become an added benefit, providing new income and also opportunities. The key achievements that we can found in this project is we can have strong support from LGUs and communities. It can also be effective use of locals, affordable materials for restoration, and it also has collaboration with researchers and stakeholders to improve success. Okay, as for the challenges for this project lack of long-term monitoring and also funding. Another reason is natural threats such as typhoons and coral bleaching deter this project, and also some methods may not work in all areas. The recommendation that we can do for this project is by increase the funding and government support. We can also do strengthen community involvement and also education. And lastly, promote ecotourism as a sustainable alternative to harmful fishing. As for the final takeaway for this project, we can say that the Bicol restoration project shows that coral reefs can recover with proper efforts. This strategy can be used in other areas facing similar issues. And lastly, ongoing conservation is crucial to protect marine ecosystem. That's all from us. Thank you.